This is the AEC Podcast, your B2B show for the best thought leadership in the industry, bringing you information, education, and inspiration, only on market scale. Put on your hard hats, let's get to work.
I'm your host, Elmer Guardado, and thanks for joining us on this market scale feature. Today we're sitting down with John Claman, Sales Representative and Marketing Supervisor at IntelliFInishing. We're going to talk about how and why finishing systems have changed over time, and more specifically about how the industry's needs are what have caused these changes. So John, let's first start by getting everyone on the same page and providing some context. Can you tell us a little bit about what you do at IntelliFInishing and more so what IntelliFInishing does?
Yeah, sure. So I'm the sales representative for the IntelliFInishing systems. What I do or what that entails, of course, is introducing various OEMs and custom coders to our types of finishing systems. And I'm also the marketing supervisor, I guess you'd say, for our parent company, CASA Controls and Automation, as well as for the IntelliFInishing branch. So I do the normal marketing things, help with our websites and our digital marketing, our social media, etc. So IntelliFInishing, as a division of CASA Controls and Automation, we provide a unique automated finishing system to the marketplace for industrial applications. And what makes it unique is really comes down to two factors. One is that it's a unique conveyor that's simply just much more flexible than traditional conveying systems used in the finishing world. And secondly, we apply our expertise at automation and controls such that we can create a smarter finishing system that's really more adaptable, more flexible, and more scalable. It can change over time and improve as other processes change and improve, or throughput needs increase, etc.
So, in the context of the finishing world, how are the needs changing that, there is a need for this more specialized and smart approach?
Yeah. So historically, the way an automatic finishing system would be constructed is based on the idea of the old monorail systems, sort of your production line, Henry Ford model way of finishing a system. So you would have a chip-based system, typically a monorail, and you would hang products on that chain, and they would move at a certain rate of speed through the various processes to arrive at the end and get unloaded, finished. Over time, that adapted a little bit to what we call power and fee systems, and that's just still a set of chains that are each independent of each other, but parts can transfer from one chain to another chain. Big limitations with both of these systems really has been that they're built for a certain set of conditions and certain specifications, and they're difficult to change. And what tends to happen is that manufacturers have segmented their parts into, I have a bunch of small, thin parts over here, and they need a certain treatment. So I'll create a system for it, and we'll send them down that line. Then I have a bunch of really thick, heavy parts over here. That small chain can't handle that, or it can't go slow enough to big, thick items. So we're going to build a much bigger, more powerful system over here to handle those parts. And what our system does is allow the flexibility to paint from very small and lightweight parts to extremely large, heavy parts on the same system, and yet modify aspects of the process to fit that part as that part hits any particular step. And so it really kind of works with lean philosophies, where instead of sending parts to all over the plant and then uniting it at the end, but having a lot of work in process at every spot, we're kind of uniting products at the finish system, sending them all through the same finish system, and then helping those products arrive in assembly as a kit or together, or if they're not necessarily something that's going to be assembled, maybe they're just a bunch of disparate parts, but still to be able to process those parts in order instead of trying to group them up and spend a lot of time in material handling, putting them all together so that the efficiency of the monorail is maximized or the efficiency of the power and freight.
So that's interesting, right? Because it seems like this is a necessary part of the evolution, right? As we're trying to become more efficient and there's more need for flexible technology solutions. Is there any pushback at all? Like, is this a natural, organic, the next step? And people who are just not doing this are just not hip to it yet, or what are you seeing? When you look at the landscape at large.
I do think that because of the prevalence of so many chain systems, and chain systems are extremely robust, they last a long time. It is not surprising to come across chain-based automated finishing systems that are 20 or even 30. Or I was at a client's a couple weeks ago that 40-year-old systems, they're still using them. They have their issues with them. Almost every chain system is built with a certain technology and process control at that moment. And obviously, the thing that is happening all around the world is that change is coming at those systems faster and faster and faster. So there have been updates in finishes such that cure times are reduced. Some steps they're able to be skipped altogether. Cleaning requirements are becoming more forgiving. There are new coatings out there that can do things that were never able to be done before, or new curing techniques, infrared being one, or other types of curing techniques that speed up the cure process. And so what happens is a lot of manufacturers and others who have automated systems get locked into a system that can't adapt very well to any of these changes. It's only really set up to do exactly what it was designed for, and it did that well at that time. But as these companies want to adapt to any of these other innovations, they're sort of locked. They have what's called a monument system, and so again, another aspect of our system that makes it unique is that it's not quite as monument based. In other words, it's not welded together; it's bolted together because we're using a technology for our conveyor that's not based on a chain whatsoever, and it doesn't have the force requirements that a chain going around a whole system has. So we can just use bolts and a rector set, if you will, technology to expand or subtract a system or scale it up to increase capacity, to add additional oven capacity, or add additional load, unload, or booths, or whatever the process may need to be as time goes on. And then that gives those customers another advantage as they move into the future. So we'll always design a system based on either their current needs or their soon anticipated needs for that system, but we'll tend to want to think about what ifs. What if you're going to need, what if you change your finish coat to some new adaptation that changes the cure setting in this, and we don't have to send that part in there for 30 minutes. Maybe it can cure in 15 minutes. What's that going to do to the rest of the system? And how can our system can adapt to that much easier?
The interesting thing about what you just said is that this is something that seems to be relatively consistent in almost every industry, right? We're getting more and more people wanting flexible hardware with maybe a software aspect, right, that changes so they don't have to make this huge investment that is not going to have long-term return just because of how fast technology is changing now, right? So is there a software aspect to it, or is the flexible part primarily these physical, changes we're seeing, right, with like being bolted down versus welded now?
There is a software aspect to the work that we do, and it's a really important aspect of it. And actually, it's based on industrial software that we used in our automation and controls of our business. And there again, the historical paradigm for industrial software has been to make it platform dependent, and to cost out that industrial software in such a way that only a certain amount of data is included, only a certain number of clients can access it, only a certain number of connections to other processes, or even the ability to connect to other processes are included. And the new paradigm, as far as I can tell, and certainly in the software we use, is a software that, with its base package, allows for unlimited data points or tags, as we call it in industrial automation, unlimited client connections, unlimited connections to other database systems, ERPs, or human resources, web-based technologies, APIs, cloud computing, virtual storage. All of those things are kind of wrapped up together in the software itself. And then, in particular, our software is relatively easy to learn, and to get in-house resources to know how to use that software. So as that system changes, of course, they can always go back to us and or other integrators of that particular software who have the skill level to change that software. But they can also relatively easy, because of sort of the open platform of the software that we're using, that allows for just about anybody to go to a certain website, download a copy of it, and start learning how to use it, take their online video classes and get more adept, and maybe even progress through the steps of certification in that software, just through their online educational opportunities. And certainly that's how a number of our programmers progress through the steps to become adept at that software. And so now, since we've been using this kind of industrial software now for 8 years, I guess it's almost 10 years now, we're at a premier level. They have sort of like, basic certified level, and then you can go through, silver, gold, and then premier. So our software engineers and programmers have seen a lot of different systems, not just finishing systems, but certainly apply what we've learned to these finishing systems. And it's a real distinguishing aspect about it when someone who's used to well, to be frank, I tend to think of chain-based systems, and especially just regular monorails, as kind of a brute strength system without much brains. And when they see our system, they're pretty well overwhelmed with the amount of information that's available in the system, and their ability to know exactly what's happening on the system, to know what every part is doing, where is it at, how much time does it have left in the system, what color is going to be applied, the ability to notify the booth of a color change well before that part gets there, the ability to notify downstream tasks like assembly that certain orders are going to be arriving in an estimated time, within just a few minutes of when that process is going to get unloaded and be ready to be assembled. So all of this information really creates a huge distinguishing aspect to the software, and opportunities for companies to take that operational technology and combine it with other operational technology, and then package it with IT, traditional ERPs and other information, for to help across the board in benchmarking facilities and processes, analysis, and just management reporting.
So it seems like, one of the common themes we're going on about here is efficiency, right? As we shift over from this more rigid Ford system to, more flexible technology. And is this also why we've seen the new standard go from feet per minute to volume per minute, when we're talking about output and what we're measuring?
That's exactly right. Systems because of the conveyor itself, feet per minute is kind of a misnomer. Our system will process. Generally, it's designed around the idea of X number of carriers, which can, if you're loading, whether you're loading 4 parts on that carrier or 400 parts on that carrier, it really comes down to total throughput per day and how many carriers can you process, the total square footage of finish that you apply. And all of those are things that report out in our system. But to address this, one of the specific things you mentioned there is the feet per minute. Our systems between processes can greatly increase their speed, and so we can run a lightweight part. We might run it at 8-10 feet per minute through a wash of whatever size, but then we might speed it up to 60 feet per minute to the next step to get to the oven. And then slow it back down, or even index it in that oven so that maybe it's going to dry off after coming out of the wash for 10 minutes. And depending on the volume of carriers that we have to process in any particular amount of time, which comes down to the ability, the need of that facility in terms of their total volume. We might index several positions in that oven. We might have several ovens set up side by side so that if one part dries at 10 minutes, but some heavy duty intricate part needs 15 minutes, then might take that longer dry off part to a different oven so that the quicker parts can continue to proceed right around it as it spends the extra few minutes in the oven. Same thing with cure. Our systems allow for sort of like train track design so that as that carrier reaches a cure spot or even in the boost, but particularly in cure, you can route the slower items to certain ovens and the faster items to other ovens, or the system can just play a logical sort of programming that just allows it to figure out what is the optimal path through that cure oven so that it spends the exact right amount of time to cure that particular product, but also maximizes potential throughput. So that kind of gets back to the technology of the conveyor itself, which is really pretty radically different than most chain systems can deal with.
Right. I feel like that level of flexibility is just it's almost hard to measure or slap a number on it, right? Because of all the possibilities.
Yeah, it really is.
Well, John, thank you so much for your time today. We appreciate your insight, and thank you for being so candid with me.